Hi, last time we implemented the dragging of the pieces using the mouse, but when we are releasing the pieces, the game puts them at arbitrary positions. So we need to notify the game that we picked a piece, and the game will control or will show, first we will show the legal coordinates where the piece is allowed to land, and when we release the piece we will adjust the position to that exact coordinates. So let's do a little connection. Before, we need obviously a reference to the main game, so we will have a reference to the game, and we can use an onReady variable and use get node like this to get the main node in the hierarchy. So let's test if this this is in game. So this works. As you see, this prints when we pick the piece, we print the main. But this will break if we rename this node, so let's not do that, and let's simply in the main script, let's assign, when we create the piece, we will assign self, which is in this script is the main piece. And this will work even if we rename things. Okay, now obviously we need to call a special function each time we click on a piece to notify the main game. So let's do that. Pick piece self, and this will be a function here in main which will receive a piece and return nothing. For now, let's print, for example, the position of the piece. Okay, we pick this one, pick this one. Okay, this seems to work. Now, obviously, we need the logic position. Let's see. Yeah, this is 0, 0. This is 2, 7, etc. Okay, now we need to compute based on the type of the piece, the legal available positions the piece is allowed to go. So let's do that. Let's do a match based on the piece type. We added all the different types of piece. We need to recalculate legal positions. Will be an array of vector 2i, initially empty, and for each type of piece we will need to compute and populate this vector. We will need the position of the piece, the logic position, which will not be in pixels but the position in the board. And let's append pos. We move the pawns one position up, but before we append this, we will compute it and we will check if it's a valid position. So to check if a position is valid, we will need to check if the coordinates are inside the board first, and if it's not occupied by another position. So let's do that. Let's make an auxiliary function that we will return bool. So if the coordinates are outside the logic boundaries of the game, we will return false. The same for the y coordinate. And if it's inside, we will check if this at pos is not null. We will return false. And if not, we will return true. We can return, we can return this like this and cover both cases. Okay, so here, if it's valid, we will append that. Now, the rest of the computations is similar, but we need some auxiliary constant arrays. For example, for the night, we will need something like this. These are the 8 possible moves for the knight. The knight can move here and here. here and here and here and here, etc. And we will do the same for the rest of the pieces. These are the moves for the bishop. These are the moves for the rook. In this case, we use the constant already defined in the Godot engine, which are equivalent to type these values, obviously. Let's continue. The queen moves are simply the rook moves and the bishop moves combined. So with these constant lists of moves, we can compute the legal moves for move in like moves. We compute the new position, and if valid position in pos, we append the new position to the legal position. For the king, it's the same, but instead of using the knight moves, you know what? Let's group that. We will use the queen moves, because the knight, the king, sorry, moves like the queen, but only one position. For the rest, we need to do two loops, two nested loops. So for move in, bishop moves, and while true, we do the same. So let's complete this inside the while true, and if it's not a legal position, we break the while loop. Let's see, move new position. Okay, this will stop the while when we reach the end of the board. For example, in this case, we will sorry. We need to let's move the position and use the modified position, obviously, because if not, the pos will never change and the loop will be infinite. So for each move in the bishop moves, we do a while loop, and we break only if the position was not legal. And the same for the other three pieces, only changing, obviously. This is the rook moves. We could extract this to a proper function, but it's only three cases. So let's print this just to be sure that this works. So if we press this bishop, it only prints the 6-1. 6-1. 6. It's because we are not resetting the position. Okay, so for each this should be local in each loop in the direction. We need a local position, so we can change it without endangering the logic. So in this case, sorry, we don't have that. So this should work. So print pos, and in this case we are in 4-1. 1, 2, 3, 4, 1, and the legal moves are 5-0, which is this one, 3-2, which is this one, 2-3, 1-4, 0-5, and 3-0. Perfect. Okay, now that we have this, instead of printing them, we will draw a little circle for the legal positions. We will make a little sprite. Let's see, to this scene. Let's use this this little. Let's change the type. Sprite 2D. Let's call it marker, and let's use this little texture. Marker, and let's add this scene with control. We can add that asset. So let's let's instantiate the marker and add it as a child, and let's set the position. This will be pos times the tile size. Mass vector 2. So let's see if this works. This needs to be the local position. The parent must be the board. Okay, this is a queen. This is a rook. Let's see. Let's add a list of markers. This will be an array. And in this function, we will destroy each marker. Okay, with Q3 and markers clear. And let's initialize the markers just in case. The same with this. And we will add. So each time we click a piece, we remove the previous markers. So this seems to work. Okay, let's try again in another configuration. This is a king, a queen, a bishop, a knight. Interesting. Okay, the markers are a bit too much. We need to remove the markers also when we release the piece. Okay. So. And also we are not changing the positions, etc. We will do the logic part of the dragging in the next video. For now, thanks for watching. Let me know if you have suggestions or questions. Please like and subscribe and share the channel with people that could enjoy it or learn something from it. And consider supporting tutorials like this using some of the links below. Thanks.